Good afternoon, everyone. Once again, in the session number 11, our today's speaker is Dr. Vijay Kumar Bohat, Assistant Professor, NSU, New Delhi. We welcome you, sir.
Thank you, ma'am.
Okay. Our speaker
Nidhi, ma'am, you are not audible to me.
Hello.
Yes, ma'am, now you are audible.
Yes, sir. Yes, sir. Sorry, sir. The connection. We lost the connection. Okay. Sir, you can continue with your session. You can start.
Okay, okay. Thank you, ma'am.
Thank you, sir.
So, good afternoon, all. Myself, Dr. Vijay Kumar Bhuhat, Assistant Professor, Netaji Subhash University of Technology, Dwarka, Delhi. First, I would like to thanks the
Yes, sir. Your PPT is
organizer
visible,
of
sir.
this workshop for providing me this opportunity. Okay, ma'am. Thank you, ma'am. So, I want to thanks the organizers for providing me this opportunity uh, to let me to present my this presentation. Okay. So the topic of the today's presentation is Grey Wolf Optimizer and its real-world applications. Now, these are the overview of this presentation. First, we will discuss briefly that what are the optimization techniques, the types of optimization techniques, and about the basics of GW algorithm, that is Grey Wolf Optimizer. And then we will see the a real-world application of it. That what I've published in this article in Knowledge Based System, a very prestigious journal. So first we will discuss that what is optimization. Okay. Normally there are many definitions of optimization, but in specifically in mathematics, we say that we have to find the values of the variables that minimize or maximize the objective function while satisfying the constraints. To understand this definition, we can take the example of the organizing institute. Okay. So suppose somebody say that, okay, we have to organize the performance of the institute. So how will you come up? Somebody says that gives you a task that you have to optimize this university. Then this task can be performed by defining the university as a mathematical function that mathematical function will have some, depends on some parameters. Okay. For example, a university, any university depends upon the number of faculties, the number of students, the infrastructure, the non-teaching staff. So these are the 4 or 5 pillars of any institution. So the performance of the institution depends upon these 4 or 5 parameters, or we can say variables. And within the constraints, we have to find the value of these parameters so that the performance is maximized. Okay. Constraints are there always, because see, suppose any university will do work if we recruit more number of faculties, but the recruitment of more number of faculties will again have its own disadvantages on the economics of the university. Okay. Means the finance will be increased. We cannot recruit more number of students because it will be a burden on the infrastructure. So within the constraints, we have to find the values of these parameters: number of faculties, number of students, infrastructure, non-teaching staff. We have to find the exact values so that the performance is increased. Now, what the objective function, example of objective function will look like. Suppose here we are taking one example, x1 square plus x2 square. Okay, so this is a very simple function, and it contains two variables that we need to optimize, x1 and x2. Now here, if I say that we have to optimize, so it means that either I want the function to be minimized or maximized. That is the meaning of optimization. Either we are going to minimize a function or we are going to maximize a function. So this is the objective function in hand that we need to optimize it. And in the given problem, it says that minimize the given objective function. So definitely, first we understand that what are this function depends upon what variables. So here we can see that its value depends upon x1 and x2. One thing that is more also required, that is the range, x1 and x2 range. Okay, so what is the lower bound and the upper bound of x1 and x2? So here we can see that the range is -10 to 10. Okay, now it's very easy. Anybody can by using their natural intelligence, they can come up with the answer of this object optimization problem, that this function will have its minima at 0, 0. x1 is 0 and x2 is 0. The function will have its minimum value the function can achieve. But in real world, the objective functions are not that much simple. And this function have 2 dimensions. So 2 dimensions means there are only 2 variables that you need to find the values within the given the range of these variables, upper bound and lower bound. But in real world, the functions are high dimensional. They have 30 dimensions, 100 dimensions. If you talk about a neural network, so that neural network have hundreds of nodes, thousands of nodes, and to find the appropriate values of weights and biases, that require means you need to find 1,000 optimal values for a particular neural network. Okay, so in real world, the functions are really complicated, and natural intelligence, by using natural intelligence, we cannot found the optimal values of these functions. So we need some algorithms, optimization algorithms, that will help us in finding the optimal solution. Now this is the example, this is the classification of optimization problems based on the search space. Okay, so optimization can mainly divide into two classes: continuous optimization and discrete optimization. Now, the problems in which variables can attain decimal values, that are known as continuous optimization. Okay, means when in the last problem that we are saying x1 and x2 will lies between -10 to 10. So x1 and x2 can achieve value 1.2, 1.3, 1.345, like this. So such problems are continuous optimization problems. The second main class is discrete optimization problem. So in this, there are some fixed value that a variable can attain. For example, if we talk about image processing, so I mean in image processing, image is made up of a pixel. So pixels can, if you talk about a gray image, grayscale image, black and white image, so those images can only at the pixels can only have value between 0 to 255, not in decimal, not any other value. So this type of problem is known as discrete optimization problem, because variables have their specific values that they can achieve. Okay, so the techniques that we use for continuous optimization problem is slightly different for discrete optimization problem. Okay, that we have to do some little modifications. Okay, then continuous optimization problem again further classified as unconstrained and constrained optimization. Suppose we know the range for the variables that for which we require or we need to find the values. If there is no further constraint apart from upper bound and lower bound, then we can say that it's unconstrained optimization problem. Okay, and apart from range, like lower bound and upper bound, if we pose more constraints, then we can say that that's a constrained optimization problem. Okay, and after that there are again for these optimization problem depends on the area, can be further classified. For this presentation, this much classification like optimization problem can be classified into continuous optimization problem or discrete optimization problem is sufficient. Now let's move to our this gray wolf optimizer algorithm. Okay, its optimization algorithm depends upon the leadership hierarchy and hunting mechanism of gray wolves. Now, first and obvious question arises that why we require or we need to understand the leadership hierarchy or the hunting mechanism of gray wolves. There are many other species available. Humans are one species, the most intelligent one that exists in this planet. The gray wolves are not as intelligent like humans. So why we are following gray wolves rather than some algorithm which based on human intelligence? So this is the answer. Because humans are more intelligent and they have a very good cooperative behavior, but it's very difficult to simulate the behavior of humans, because the mind of humans, it's very difficult to predict. And it's very difficult to predict that what I'm going to do next after this class, what will be my actions if I'm not following a if there is a timetable, then definitely you can predict that after this class sir will take another class or like that. But the natural action of humans is difficult to predict. The other species like gray wolves or birds, or we can say ants, the behavior of these species mainly is all about finding the food, surviving, and nothing else. So their simulation into real world by using mathematical equations is comparatively easy, uh, rather than we simulate the behavior of humans, because human behavior is very complicated. Uh, the time when somebody simulate the human behavior, then that algorithm for optimization will be the best algorithm that will exist in the world. Okay, so till now the simulation of human behavior for solving optimization problem is not yet done. Okay, now in the nature there are many species. Okay, gray wolf are one of them. There are birds, there are ants. Previous there are few species that are extinct like dinosaurs. Okay, there's a reason behind that the extinction, because if you dinosaurs are not that much cooperative. Okay, मतलब we have not listened about so much cooperation between them. But at the age of dinosaurs there are one species called ant. Ant still is there in the, they are not extinct because of their cooperative behavior. They survive together. They don't hunt food alone. They do they have the foraging behavior, means they are looking for food, but they are in group. So this particular quality creates difference between the uh, ant and dinosaurs. Okay, so there's a huge difference. That's why optimization algorithm is based on the swarm intelligence of ants, is based on swarm intelligence of grey wolves, is based on swarm intelligence of birds. A very popular algorithm that majority of you have heard of it, like particle swarm optimization. Particle swarm optimization completely it's the simulation of the food foraging behavior of birds. Okay, so there are different algorithms, and all algorithms have their own advantages and disadvantages. There's an algorithm called no free lunch theorem that describes the phenomena that no optimization algorithm can solve all the optimization problems efficiently. Means one problem will be for one optimization problem, but we cannot say a single algorithm can solve all the problems efficiently. So that's why this particular algorithm makes this area very much interesting, because we know that nobody can make an algorithm that will solve all the optimization problems. So we require specific optimization algorithms for specific real world optimization problems. That's why a lot of researchers are working in this area. They are trying to create problem specific optimization problem algorithms. Okay, problem specific optimization algorithms. And researchers are continuously observing the nature. Whenever they found a behavior of one species that can result after its simulation, that can solve a optimization problem, they try to come up with a optimization algorithm out of it. Okay, so gray wolf optimizer, as I said previously, that simulates the leadership hierarchy and hunting mechanism of gray wolves in nature, proposed by Mirza Lili et al. In 2014. And after when it was proposed, it's quickly gathered the popularity in the research field because of its novel equations. Like we will see in this presentation, gray wolves are considered as apex predators, which they are at the top of the food chain. Means if we talk about the food chain, grey wolves are top of it. But nobody eats grey wolves, nobody hunt grey wolves. Grey wolves are surviving on the prey. There are few qualities that makes grey wolves different from other species, that grey wolves prefer to live in a group, or we can say pack. Each group contains 5 to 12 members on average. That this particular behavior that all we have seen in 90s, there was a cartoon Mowgli. In Mowgli we have seen that there was a boy in the jungle and he used to live with a pack of wolves, and in that pack of wolves there is a social hierarchy. There is a boss, and the other wolves follow their orders of their leaders. Okay, so that's a phenomena that exists in the gray wolves, that they have a hierarchy between them. All the members in the group follows a very strict social hierarchy, a dominant hierarchy. That's the first level is called alpha wolf. Alpha wolves are the leaders of the pack. Okay, alpha wolves are the leaders of the pack. They are dominating, and they are mainly responsible for making decisions about hunting, time to walk, sleeping place, and so on. Okay, so all the pack members have to follow the order of the alpha. So there are different ways by which they enforce their orders on the pack members. If somebody doesn't follow their orders, then they have to punish that particular member. So that's also the responsibility of the alpha wolf. That whole group must follow their orders. So this is the whole social hierarchy in which we can see that alpha wolf is at the top and are the most dominant wolf in the pack. Okay. The second one is the beta wolf. The betas wolf, we can say that, are the subordinate wolves which help the alpha in decision making. So alpha needs to enforce their orders on the pack of the member. So beta wolf passes the order to the other pack members. It reinforces the alpha's command throughout the pack and gives the feedback to the alpha. The beta wolf can either be a male or female. It is generally we say that it's the second best candidate for to be the alpha wolf. When the alpha passes away or becomes very old, the beta wolf takes the position of the alpha. Now, after alpha beta, the third level is called delta wolf. The delta wolves are the subordinates of beta wolves. Okay, delta wolves have to submit themselves to the alpha and beta, but they dominate the omega. That is the last hierarchy, the lowest level in the wolves' social hierarchy. There are different categories of delta as follows. There are different jobs the delta wolves have to follow, like scouting, responsible for watching the boundaries of the territory and warning the pack in case of any danger. Sentinels. The sentinel wolves are responsible for protecting the pack. Security, elders, hunters, caretakers. Different jobs are there that delta wolves will follow. The fourth level is called omega, and omega wolves are considered to be the scapegoat in the pack. They have to submit themselves to all other dominant wolves. They may not seem important individuals in the pack. They are the last one. They are the last allowed wolves to eat. They are not that much important, but as they are the member of the group, so the group does not want to lose them. So that's why they're always in the group, but will be dominated by all three superior levels. Now, this is one we can say the social hierarchy of the grey wolf. Okay. Now, how this social hierarchy is going to help us in our optimization problem? Now, what the author, that is the author of this algorithm, Mirza Lili, what found good about it? So that we will see when we are going to see the mathematical equation of the GW algorithm. Okay. Now let's second focus on the hunting mechanism of grey wolves. Okay. So GW algorithm is based on two phenomena. First phenomena is the social hierarchy of the grey wolves, and the second phenomena is the hunting mechanism of the grey wolf. There are two pictures in this slide. In both the pictures, you will see that the grey wolves encircle the prey. Okay. So grey wolves usually attack a prey which is much larger size as compared to them. Means a buffalo or a bison. So generally these preys have a large size than grey wolves. So for a single grey wolf to attack a prey, it's difficult. So that's why the cooperative behavior among the wolf is very much required. A single wolf cannot attack a prey. A prey can easily outperform the wolf. So they come up with a strategy that they will hunt a wolf or hunt a prey by using the cooperation behavior. And during the hunting, the grey wolves usually encircle the prey. And what they do, that they encircle it and they do not attack instantly after encircling the prey. They wait for the good movement. They start moving with the prey in the circular manner. Okay. So what the prey, this encircling of the prey, the movement of the prey around the predators mentally harass the prey. Okay. Then there's a time when prey stops moving. Why? Because the prey knows that because it's surrounded by the predators, the grey wolves, so it's not a good time for me. That mental harassment of the prey results in the movement of the prey in in small velocity, we can say. The speed of the prey will be decreased because of this harassment uh, performed by the pack of the grey wolves. And with lapse of time, the grey wolves shrink the circle. Okay, and after a appropriate after the circle is getting small with lapse of time, then they attack the prey, which is beneficial for them. Okay, so these encircling the prey and shrinking of the circle with lapse of time, this particular thing results in the killing of the prey. Okay, so these two important phenomena of this grey wolf behavior allows the researchers to come up with a optimization algorithm that is called GW, Grey Wolf Optimization Algorithm. The first important thing, that is the social hierarchy of the grey wolf, is very good. And the second thing is the attacking mechanism, hunting mechanism of the grey wolves. Okay. Now, these two things must be properly must be properly mathematically modeled so that authors can come up with a optimization algorithm. Okay. Now let's see. These are the two equations that are responsible for, we can say, the encircling of the prey. Okay. Now here, suppose the position of the prey is xpt and the position of the wolf is xt. Okay. Position of the prey is xpt and the position of the wolf is xt. So first, we will calculate a distance between the prey and the wolf. Okay. Uh, Grey wolf optimization algorithm is a population-based optimization algorithm. Okay. Initially, what we do, that we initialize the population. Okay. Let's take example of that we have taken previously. This is the objective function. Okay. Suppose I want to implement Grey wolf optimization algorithm for solving this simple objective function. Okay. So the first step will be the initialization. For example, suppose I want 5 wolves to solve this particular optimization problem. Means, as these algorithms are based on population, so that is one, we can say, one parameter that we have to decide previously. Okay. So suppose we decide that with five grey wolves, we try to come up the solution of this optimization problem. So we'll initialize 5 grey wolves within the given search space. So this optimization problem consists of 2 dimensions, x1 and x2. So in the initialization step, what we will do, that we will initialize 5 grey wolves within the specific range randomly. Suppose the range of the variables is -10 to 10. So randomly we will decide the values of the grey wolves: -6, 7, 3, 2, 1, 8, -4, 6, -5. So these are the 5 grey wolves. First grey wolf having position -6, -5 within the given range. Second grey wolf having the position 7, 3. Third grey wolf 2, 1. Fourth grey wolf 8. Fifth grey wolf 6, -5. Okay. So these are the positions that we have initialized. Means we don't know how to start, where to start. So randomly we allocate the position of the grey wolves in the search space. The search space is for every variable, the search space is between -10 to 10. So for the first dimension, we will initiate the solutions, and for second dimensions, for every grey wolf, we initialize 2 positions, first dimension and second dimension. If the dimension in the problem is much more than 2, then the size of our vector, that for every grey wolf is a vector, basically we can say each grey wolf is a vector. So the size of that grey wolf will be increased. If there are 10 variables, then every grey wolf will have 10 values in it, and we require the optimal values for each and every dimension. So this is the first step, that we initialize the grey wolves. Second step is fitness evaluation. Okay. Now we need to evaluate the gray wolves, that how better they are, what is this position in the search space. So that fitness value we can get it from by putting the values of these dimensions or solutions, we can say, in the objective function. So the fitness of the first gray wolf can be calculated by -6 whole square plus -5 whole square. The second gray wolf, the fitness we can calculate from 7 square plus 3 square. And like this, we can evaluate the fitness of all gray wolves. The last one is 6 square plus -5 square. As our criteria is minimize the given objective function. Okay, so which gray wolves having the least fitness, that will is we can say that is the best solution that we have got so far till now. Okay, so the social hierarchy of gray wolves talks about like there are alpha wolves, beta wolves, delta wolves, and omega wolves. Okay, so whatsoever the best solution we have, like in this example, we have a population of size 5. Okay, so the best fitness value here in this example, 2 square plus 1 square, which is equals to 5. 2 square plus 1 square. So the fitness of this gray wolf will be the best fitness. It's 5 only. And rest of the gray wolves will have large fitness. So this gray wolf will become the alpha wolf for us. Okay. The second best will become the beta wolf for us. And third best will become delta wolf for us based on the fitness of the solution that we have initialized in the search space. Okay. So that's how we will create alpha wolf, beta wolf, and delta wolf. For example, let's take this wolf is become beta, and suppose this one will become delta, for example. Okay, so we have the position of alpha wolf, beta wolf, and delta wolf. The values of these dimensions will known as this vector is known as the position of the alpha wolf, and its fitness we can calculate by putting this positions into the objective function. The first dimension into the x1 and the second dimension will put in the x2, and we calculate the value of the objective function by putting the value of the alpha wolf in it. Okay, now we have got two things: the position of the wolves and the fitness values of the wolves. And based on the fitness values, we can decide which one is alpha, beta, and delta. The last category of wolf, that is omega, is not present in GW. While simulating this algorithm, the author finds out that only 3 wolves like alpha, beta, and delta are sufficient for finding the optimization problem. So this is all about the social hierarchy of gray wolves in GW algorithm. That first we initialize randomly the solutions, then we calculate the fitness of the solutions, evaluation, fitness evaluation, and then we decide the who is alpha wolf, beta wolf, and delta wolf. Okay. Now these 3 wolves will help in the movement of the pack in the search space. Now we can start discussing these two equations, D and XT. So the second phenomena, that is the encircling of the prey, and with lapse of time the shrinking of the circle, and then attack of the prey. So this much is for these phenomena. This is the mathematical equation that has been proposed by the prey. The first equation, that is for D, the author is calculating the distance between the position of the wolf, like xt here is the wolf position, which we have initialized like we have shown in the slides. Okay, and this xpt is the position of the prey. Okay, so we know the wolf position because we have just initialized in the first step. We have done the initialization, but we don't know the position of the prey. So while solving any optimization problem, you don't know the position of the prey. For because we consider optimization problem as black box. Black box means we know the mathematical function of the problem, we know the number of variables, or we can say dimension of the problem, We know the ranges of the variables, the upper bounds and lower bound of the those variables, but we don't know about the what is prey in that problem. Okay, so that the finding the prey thing has been solved by considering alpha, beta, and delta wolf, their position as prey position. Now, why we are considering alpha, beta, delta wolf as preys? Because see, these are the best wolf till now we have. Matlab, we have initialized a random population of wolf in the search space by using random numbers in the given range. We initialize them, and their fitness is best. So we consider that these wolves know about the prey location. All wolf must follow them. Okay. So every wolf, all other hunters, including alpha, beta, and delta, they follow the position of the alpha, beta, and delta wolf. And the next location for any wolf in the search space has been decided by the average taken of alpha, beta, and delta wolves. How? First, we calculate the distance between from every wolf to alpha, beta, and delta, like this. C1 dot x alpha minus x. X is the position of the wolf, and x alpha is the position of the alpha wolf. C1 is a random number to R2, where R2 and R1 as well as both in these equations are random numbers between 0 and 1. So C is basically 2 into random number. Okay. And the values of these random numbers between 0 to 1. Why this C is 2 into R2? Obvious question comes in the people's mind that why C is equals to 2 into R2, why it is not only R, a random number, or 3 into R2, is based on the experiments performed by the author. So they found this value 2 into R2 is suitable for this simulation of the grey wolf hunting mechanism. So first we calculate a distance with respect to alpha, beta, and delta for every wolf. And we multiply C1, coefficient C, to every position of the wolf. This coefficient is 2 into R2. Why we apply a random number to the position of the wolf? Because see, this multiplication with a random number introduce stochastic nature. Stochastic behavior in the algorithm. Stochastic behavior because see, we are searching for the values of the optimal solution, and we don't know about anything about the optimal solution where it is in the search space. So we need to search it. Okay. So this multiplication with 2 into R2 produce randomness in this grey wolf optimization algorithm, which is quite good for the optimization algorithm, so that it will not stuck in the local optima. That will help in producing abrupt step size in the search space. So for every grey wolf, we calculate the distance with respect to alpha, beta, and delta, and we say that d alpha, d beta, d delta. Then we calculate the next possible location for every grey wolf with respect to alpha, beta, and delta. For this, the equation is x alpha minus a1 dot d alpha. Okay. Now here, with this a1, they try to introduce the encircling mechanism. Now let's look how a1, what a1 is. Okay. A is again a vector. Its value is 2a r1 minus a, where a is a number that varies from 2 to 0. It linearly decreases from 2 to 0. So when we start grey wolf optimizer, but basically these all algorithms, all SOM intelligence algorithms are iterative in nature. Means iteratively they come up with the best values. So we run these algorithms for specific number of iterations. So initially, suppose we have 100 iterations. We are running our algorithm for 100 iterations. So initially the value of the small a will be 2. But as the iteration goes on, as the time, with lapse of time, the values of a is linearly decreasing to 0. So at the last iteration, that is 100, the value of the a will become 0. Now what it does, how it comes up with the encircling mechanism. Okay, so A is equal to 2A R1 minus A. Again here R1 is a random number between 0 and 1, just to produce a stochastic behavior in the uh, algorithm. Now this 2A R1 minus A, initially the value of small is large, that is 2. Okay, so the step size of the gray wolf will be large initially, and with lapse of iteration this value of A is decreasing. So the, we can say the encircle, the circle they have made around the prey will be decreasing. As the value of small is decreasing, we can say that the circle of around the wolf is decreasing. Because if you really look at this value 2A R1 minus A, where R can be a random number. So suppose the position of the prey looks like this. So based on this equation A, the next solution can be anywhere around the prey. Okay, because 2A R1 minus A. So if R1 is a small value, then this can become positive. With large value, it will become positive. For small value, it can become negative also. So all around the prey, you can have the position of the grey wolf. Okay, and we want to search around the prey a lot. Means suppose alpha is our best solution. So we want to search around the alpha a lot so that a better solution as compared to alpha we can find. Okay, so basically with the help of this A vector, we're ensuring the initially the circle is big, and with lapse of time the circle is shrinking. Okay, so let's see this with the help of the diagram. Suppose this is the wolf that we want its movement in the search space. So first we calculate d alpha, and here is the alpha wolf, position of the alpha wolf. Here is the position of beta wolf. Here is the position of delta wolf. So we calculate the d vector, the distance between alpha, beta, and delta with the wolf, and then we calculate the respective locations with respect to alpha, beta, and delta wolf by using these three equations. Okay, so and then we take an average of these three locations as the next possible value for these wolf. Okay, so after calculating x1, x2, and x3, the next possible location of x for the wolf will become this location, the average. So that's how all the gray wolves are moving in the search space iteratively. Okay. Now there are two phenomena that just a second. Sorry for the interruption. Now there are basically two important phenomena that we look for in every nature-inspired algorithm. The first phenomena, that is exploitation, and second phenomena, that is exploration. So we must ensure that these two phenomena exist in every optimization algorithm. Now first we try to understand what is exploitation. Exploitation means whatsoever the best solution found so far we have while doing the search process, we need to exploit them a lot. Exploit them means around the position of the solutions, we need to find more values around it. Okay, so that is this is phenomena is known as exploitation. Okay, and how gray wolves ensuring that exploitation is there is by using the varying the vector a, small a. Okay, vector the capital A depends upon the value of small a, and small is linearly decreasing from 2 to 0 in the course of over the course of iterations. So when mod of a, the magnitude of a is less than 1, that is, we can say is negative. So it means that wolves are attacking towards the prey, which represents an exploitation process. Okay, so the wolves are going towards the prey. So is the and we know that preys are alpha, beta, and delta wolves, the first three best wolves. So we are moving towards those best locations best possible locations that we have found. So that is exploitation of those good solutions. Okay. Now exploration. Exploration means we are diverging the solutions throughout the search space. Now how Greybull's optimizer is ensuring this particular thing. Here we can say that when the magnitude of A is greater than 1, in that equation that we have, capital A equation 2A R1 minus A, because of R1 value, it can be negative, it can be positive. Okay. So when the magnitude of this A is greater than 1, the wolves are forced to diverge from the prey. What we can say that, suppose this is the position of the prey and these are the gray wolves location somewhere around it. So when mod of A is greater than 1, so the gray wolves are not going towards this location, gray wolves are moving away from this location. Okay, so this is called exploration of the search space. We are looking for best, more possible locations. Okay, and if A is less than 1, magnitude of A is less than 1, sorry, then we can say that the wolves are moving towards the prey location. Okay, so this is the exploitation of the good solutions. We are trying to find more better possible values, to have a better fitness values. So this is exploitation. So these two phenomena are available in gray wolves with the help of this capital A and small a. Small a is linearly decreasing from 2 to 0. So initially when the value of small is large, that is 2, we can say that wolves are exploring the search space, and when the values with lapse of time, means with lapse of iterations, the GW is losing exploration and finding more exploitation of the best solutions found so far. So this is how we ensure the exploration and exploitation in the GW optimizer. Sorry. So this is the algorithm, but how this algorithm looks like. So in the first step, we initialize the parameters of the GWO and the population of GWO. Okay. So in the first step, set the initial values of the population size. Suppose we have, like in the example, we have taken 5 gray wolves. So we'll decide how many population size you require for solving a optimization problem. Okay. Then after that, the value of small a, which is pre-decided that it will start from 2 and with lapse of iteration 0. Capital A and capital C depends upon the random vectors, random numbers, and maximum number of iterations. How many iterations you need to run your algorithm? So two decisions you have to make before starting of the optimizer algorithm. That is what is the population size and how much iterations are required. So generally, if the problem is complicated, so we go for with large population size and large number of iterations. If the problem dimensions are less, then we decide with less population size and less number of iterations. Okay. So this is about the parameter initialization. And after the parameter initialization, we initialize the population in the search space randomly, that we've seen in an example, and we evaluate the fitness of every search agent. Suppose we have 10 wolves, so we calculate their fitness, and based on the maximization or minimization criteria, we decide the best 3 solutions. What are the best 3 solutions? And we consider them as alpha, beta, and delta wolves. Okay. After that, we update the position of the gray wolves for every iteration. In every iteration, we move the position of the all the gray wolves with respect to alpha, beta, and delta wolves. So after every iteration, we again calculate the fitness. We try to update our alpha, beta, and delta wolves. As all the wolves are moving, so alpha, beta, and delta wolves are also moving. And every time, the first 3 best wolves will become alpha, beta, and delta, and all other wolves are going to follow them by considering them as the possible location of the prey. So for specific number of iterations, this phenomena is keep on going. Okay. And at the last iteration, the value of the alpha wolf, we can say the position of the alpha wolf is the best possible solution that we have found so far for the optimization problem. We do the solution and updation, and at the last, after the termination criteria, that is which is generally the exhaustive, we have exhaust the iterations, so we will terminate the algorithm, and the solution is the position of the alpha wolf. Okay, produce the best solution in terms of x alpha. Now suppose I've taken one example in the slides. Here in this example, the initial population of grey wolf for the same problem that we have here, x1 square plus x2 square. We need to minimize this problem. Okay, minimize. And here we can see that the values of this are between -10 to 10. Okay, just a second. Taking a pause. Sorry for the disturbance. Now, for example, we have initialized the population randomly between these subspace, and the problem is of minimization. Okay. Now, randomly, like by using a software, I've initialized these values. So as this problem is continuous, so the possible solution can attain a decimal value like 0.92, 3.7813. So infinite number of values can be there. So we have initialized 5 grey wolves, or we can say 5 solutions for the problem x1 square plus x2 square between the range -10 to 10. -10 is the lower bound and 10 is the upper bound of the problem. Okay. So we calculate the fitness of every grey wolf. Okay. So the first grey wolf fitness will be 15.15 after the calculation. Second having this, third one, fourth one, fifth one. So we can observe that if the problem is minimization, so this one will become the alpha wolf for us. This one will become the beta wolf for us. And this one will become the delta wolf for us. Alpha, beta, and delta based on the fitness value. Okay. Now, initially we have the parameter value, that is small a, that is equals to 2. So in GWO, there is only one tuning parameter. That is small a, because capital A depends upon the value of small a, 2a r1 minus a, and capital C is a random number. So capital C is not a tuning parameter because its value is always fixed, always 2 multiplied with a random number. So it's not a tuning parameter at all. Its value is kind of fixed. Capital A depends upon small a. This 2 and r1 is again a fixed value. So this small a is the only tuning parameter available in this algorithm. And that's how this GW algorithm is different from other optimization algorithms like genetic algorithm or particle optimization algorithm. If you see this algorithm, the equations of them, you will find that they have 2-3 tuning parameters. which make their use tough for solving optimization problem. Because if you apply those algorithms in a particular optimization problem, you need to find the best possible values of those parameters, tuning parameters. Then you can apply those algorithms for solving a particular optimization problem. But GW is only having one. So that's reduce the task. That makes this algorithm a very available and well established optimization algorithm in the literature. And that is the reason of this popularity, because researchers have to do a little task in implementation of this particular algorithm. So as we can see, if this is the initial population of gray wolves, so this is the fitness, okay. And if we run this with this population, we apply the gray wolf for 5 iterations. So look at the fitness of the gray wolves after 5 iterations. So we can see that previously we have the largest fitness, that is 77.68, but here we are having it 17, and the best solution is having the fitness 9.91. The second best is 9.46. The third best is 9.6. So only after 5 iterations we can see a good performance given by the gray wolf optimizer. And if we run this algorithm for 50 iterations or 100 iterations, we can see a possible decline in the fitness value. That is, we are moving towards the minimization of the given objective function, or we are finding the suitable values of the parameters of the objective function. So that's how the gray wolf optimizer work. Okay. Now, second point, it's real world implementation, where we apply in the real world. Okay. So as I've said initially, that any system which consists of any optimization problem, okay, if any system you want to optimize, first you have to represent that system in terms of a mathematical objective function. And once you are able to represent a particular function, optimization problem into a function, then you find the parameters that are representing that function, and you can find the values of those parameters using this GW algorithm. One real world problem, that is to increase the accuracy of a neural network. Okay, so for that, to improve the performance of the feed-forward neural network, for this problem, I have utilized one nature-inspired algorithm, and here I will discuss the its possible application. Okay, so a representative architecture of a feed-forward neural network is present in the slides. So we have an input layer in the neural network, followed by hidden layers. There can be many hidden layers, or there can be only one single hidden layer, which consists of multiple nodes. And there is output layer. So this is the flow of the feed-forward neural network. Okay. Now the performance of this neural network mainly depends upon the weights and biases. Okay. Means in the input layer, with every node, there are two things that are associated: weights and biases. So for every node, these two things are associated with it, and to know the value that is suitable for these weights and biases, so that the accuracy can be increased, that's a tough task, because generally a neural network consists of thousands of we can say neurons. Okay, and for every neuron there are weights and biases are associated, so there are many values are there. Okay, so first, before the application of GW or any nature-inspired algorithm, first you have to represent your solution, that what your as we have said, that we will initialize the gray wolves in the search space. So what is the vector of the gray wolf, how it is look like? Okay, first we have to decide that how is the vector of the gray wolf, or how is the vector of the solution of the problem will look like. So here, this B not B1 up to BM minus 1 is the hidden layer. Suppose I've considered only one hidden layer. Okay. So with all nodes, the associated bias I will represent first with B0 to BM. Okay. And after that, this green lines uh, is represented the weights from the input layer to the hidden layer, and this yellow represents the weight from the hidden layer to the output layer. Okay, so this is how my formation of my GWO vector looks like. So once we know that, okay, and we need to know the range of these weights and biases. Okay, so it varies from neural network to neural network. Generally, they lies between -1 to 1 or 0 to 1. Okay, so these two are the ranges. So you can use this optimization algorithm for optimizing, increasing the classification accuracy of SVM, deep neural network. Evolutionary deep neural network is one of the emerging area right now. So it depends upon the architecture of the neural network, and the components, the specific parameters that affects the values of the performance of the classifier, that we need to arrange them in a formation of a solution. Okay, so our GW vector looks like that, all the possible values and the ranges depends upon the neural network. Okay, 0 to 1 or -1 to 1. So in between them, we will initialize many possible, the population of gray wolves, the multiple population of gray wolves, and we will apply those possible gray wolves in the classifier, and we evaluate the accuracy of the classifier given by the classifier. So suppose I generate 30 gray wolves. Okay, 30 gray wolves means 30 combinations of weights and biases. So I will apply all the combinations of 30 combinations of weights and biases in the architecture of the neural network. I will have fitness values, means 30 classification accuracy will have. Okay. So I will see that which classification accuracy is best. If somebody, if definitely some of them are good, some of them are bad. So the good will become the best, will become the alpha wolf, the second best beta, third best delta, and I will run the gray wolf iterations on those accuracies. All the rest of the gray wolves will follow the alpha, beta, and delta wolves. So by running this algorithm for 100 iterations, 200 iterations, the values will be updated, and we can observe the increase in the classification accuracy of a classifier. The same way, uh, you can increase the accuracy of the finding the appropriate values of the parameters of a particular classifier by using this nature inspired algorithm. Okay, there are many other areas. In this particular application, the objective function is to minimize the error, or we can say the maximize the classification accuracy. Both things are quite similar. The output layer and the proposed solution. So we need to minimize the error between the two of them. Okay. So either you can go for the minimization of the error, or you can go for maximization of accuracy. That two criteria you can follow in optimizing a particular machine learning model. In literature, you can find many number of good number of articles on this particular thing. Now, with the help of this algorithm, these algorithms are applicable for complex optimization problems. Okay, if we talk about the computer science branch, then the areas like image processing. So basically, I've used this uh, particular algorithm, or we can say nature inspired algorithm, in solving multiple problems. Like I have papers on multi-level thresholding of images. Okay, Multi-level thresholding of images is also known as image segmentation. Okay, if we want to segment an image into 5 different classes, so for that you have to find uh, 4 different thresholds. So 4 different thresholds divides the image into different classes, and we can separate the foreground and background, or we can consider it on a particular property of the image, a particular location of the image. So to find those threshold levels, because see our, as I said, that all the pixels varies from 255, 0 to 55. So find the appropriate threshold levels between 0 to 55 in the histogram of the image. Like this is the image histogram. So if I simply ask you that, okay, divide this image into 3 classes. So simply put the histograms over there, because you will find that this class is quite different from this one, and this one is quite different from two. So it's a very easy. But in the real world, the histograms of the images are quite complicated. So we need to find the threshold, appropriate threshold, by using Otsu's thresholding function or Kapoor's entropy. These are the functions that help us in determining the optimal threshold. So by using GW algorithm or nature-inspired algorithm, we can apply these particular algorithms for multi-level thresholding of images. Participants can contact me if they want to work in this area. There is one more area, that is face image super resolution. I've also utilized this particular technique in solving we have low resolution images in real world, to fill them with more pixels and to increase their resolution. So nature inspired algorithm can also play their part in that also, in that real world problem. And it depends upon area, like some people belong to civil engineering or electronics in digital signal processing, they can find the application of these particular class of algorithms. Okay, so these are the references of this presentation, that I published a paper on this application on training of feed farrell neural networks, and the original paper of Gray Wools. Now I request the participants, if they have any doubt, they can raise their we can discuss about it. I'm providing my email ID in the chat box of the meeting. Thank you all. Yes, I think Suraj sir have some query. I think I will try to make you the administrator of this so that you can ask question.
Hello. Yes, sir. Suraj sir is now active. Suraj sir, please ask your question.
Yes, sir. Yes, sir. It was a nice presentation, sir. I want to know that in Gray Wolf optimization, as we have categorized the wolf in 4 category: alpha, beta, delta, and omega. But in solving, we are taking only this alpha, beta, and delta. What is the role of the omega type?
Yes, sir. So, see, social hierarchy of gray wools consists of four different type of wools. But while doing the mathematical modeling of the this algorithm, the author found that three wools are, like we've seen in this algorithm, that all the wools are moving towards the position of the alpha, beta, and delta wool. So these through wools are contributing in the optimization search, we can say search process. But if we include the last wool, that is the last one, omega wolf, that will degrade the performance of the algorithm. That is degrading. So, like you have got a very good question, that why not omega wolf, or why we cannot why we not include five wools. So, based on the experiments, by including those wools in the code of GWO, we can find that okay, this addition of the four wools is not helping me in enhancing the performance of the optimization algorithm. Same thing the author finds out it. Same experiments I have also done in the past. The MATLAB code of GWO means the author name is Syed Ali Mirza Lili, and he's running a web page, syedalimirjalili.com, I think. In Google, you can search, and in that web page, you can find the source code of GWO in different languages like C, C++, Python code, and MATLAB code is also available in that website. So by downloading that code, you can perform experiments, different experiments, that why we are not adding some component. And this is how the research progress. We found some gaps in the one particular algorithm, like you have found that why not the fourth wolf addition is there. So we have some query, then we try to do the experiment and we can get the solution, why what it will do, the addition of the fourth wolf while application of this algorithm in different real world problems. And definitely one research gap that I personally found in this algorithm is that in this algorithm, we are talking about the hunting mechanism of the gray wolf and the social hierarchy of the gray wolf. We are considering alpha, beta, and delta as prey. But the movement of the prey, that is not yet defined, because alpha, beta, and delta wolf are also predators, and their movement is also depends upon the predator equations, that are the equations of gray wolves. But if somebody propose a prey phase, a phase that is responsible for the movements of the prey, consists of some equations, mathematical equations that will apply, that will come up, that will introduce new trade-off between exploration and exploitation in this optimization problem. So that can be one good study, and definitely a very good research article, research paper can come from this work, the addition of a new prey phase in this gray wolf optimization algorithm.
Sir, among these optimization like ant colony, particle, honey, cocoa, fire flow, bat, and so on, what are the complexity and which one is preferred, or which one will give the result, optimization result better?
Sir, the answer of this question is, I can say that there is no correct answer of this question, because see, there are initially I've said that there are many optimization algorithm. There are many nature inspired phenomena are there, and we have the humans have developed many optimization algorithms based on the different phenomena in natures. No algorithm can optimize or can solve all the optimization problem efficiently. That cuckoo search is basically good for some one particular problem. So GW algorithm will be good for some other optimization problem. So only with the help of comparison, we can found that this algorithm is good for this particular optimization problem. But by reading the literature, suppose you are working in the field of image processing. So by reading the papers of the image processing, by looking at the other research, that those research will show that what are the different performance of the algorithms, different algorithms. So with that, you can find some clue that what are the algorithms that can help me in a particular area. Okay, so we cannot say that one algorithm is good or other one is bad for a particular problem. So researchers are always in search of a novel equations or the improvement of these algorithms, because one algorithm is not sufficient for all the optimization problem. And there are different techniques: GA, PSO, GWO. So generally, what the researchers do is the techniques which are not complicated, like GW is very easy one, because the number of tuning parameters are less. Only one tuning parameter is there. So these algorithms will become more catchy for the researchers, and they apply these algorithms a lot. That's why we can say that in the recent times, we found that GW become very popular because of its citation count. Citation count doesn't show the effectiveness of the algorithm, but we can see that this algorithm will become more popular. If somebody comes up with a very complex optimization technique, maybe that technique was good, maybe, but we can, in the past, I've observed that the community follows the way in which the techniques are not much complicated and easy to understand for the community.
Sir, all these technique are used only for searching, or we can also do other operations on this?
No, basically these algorithms are optimization algorithms. So all what they can do is only they can search optimal values for a minimization or maximization. That's the only task these algorithms can do. Wherever the specific values are required for a system, then we can apply these algorithms. The application of these algorithms depends upon the individual, how they apply, how they can optimize the system.
One thing more I want to ask, that is GWO suitable for multi-objective problem?
There are many articles for the variants of GWO. Means to convert a GWO, basically GWO is single objective optimization problem, and to convert into multi-objective, there are different ways. Means there are different techniques available in the literature. You can implement the multi-objective variant of GWO by using non-dominated sorting, or there are different methods, archive-based methods. So variants are available of GWO, and their MATLAB codes are available. So particularly in your for a specific problem, you have to apply all the different variants of multi-objective version of GWO, and you can observe the performance of them.
Thank you, sir. Both nice, sir.
Thank you. Thank you all.
Thank you, sir, for your wonderful experience you have shared with us. And I hope, sir, you will share your PPT also.
Yeah, ma'am, I will share it with the Divangan sir.
Okay, sir.
Okay.
Thank you, sir. Thank you so much.
Okay, thank you all.
Participants, please give your feedback and quiz also. Link is active for some time. Please make it fast.